Hello everyone. We're going to take you through the program that we made to run. So as you can see that first part of it, that is the library, gives us to include us to things. So in C programming, it's just to bring the what kind of library up. But here we're dealing with math. Like that's why that included the math. Then the next line using namespace, that one you can either ignore it because when you're going to run that program, it won't be same. So we are to calculate the roots of quadratic equation. Remember, quadratic equation given by b times b, and then okay, like we're going to get the discriminant, which we have b, asterisk b, and then 4. Remember, in the other root for quadratic equation, each equation is written in that form. And then we're going to find the discriminant greater than 0. So we shall get the first root and then the second root. The negative b plus the square root of the discriminant divided by 2a. And then the second one also will be that, and then minus the square root divided by 2a. And then now we shall get the roots. The first root will be the roots are real and this thing. Then you end. And then the second root also find the second root. Remember the real and distinct. So let me call my other question about the other part of the program. We'll talk about the real part and then we'll run.
So as you can see here, we are going to look at the case where we have the discriminator equal to 0. I think it's here. So I think my colleague has talked about it. We are going to use the formula as negative b out of 2a. Yeah, 2a. So as you can see here, we have roots are real and equal. So we have the first root equal to the second root because their roots are real and equal. So in that case, so we are going to look at this case where elsewhere where we have the doubles. You have real part and the imaginary part. So we are going to see that the real part is got from negative b out of 2a, and the imaginary part is got from the square root of the discriminant, which is b squared minus 4ac from that bulldozer method. And we are seeing this. So we are going to have roots are complex and conjugate of each other. So we have a complex one and the conjugate. So we're going to see that the first root is got by saying by the real part plus the imaginary part I which means imaginary, and the other one is got from the real part minus the imaginary part I. Yeah, so you can follow this because the great thing is to know where these brackets are supposed to be. Get so we are going to look at another formula in our formula. Another formula in our formula is saying int main of you know how it's done. So in this case, you're going to enter a formula which says which allows us to enter the coefficients of a and b so that we can find the imaginary, the real part, and everything. So as you can see, calculate roots of a, b, c. So we are going to return 0. So and if I try to comply this, uh, so if I'm trying to comply this, let us give it some time. These things are not for rushing. As you can see, it's telling us error 0 and warning 0, which means we are safe to go. Our program is correct. So as you can see, when I try to run this, sorry about that. So you can see it tells me enter coefficients of A, B, and C. And if I enter A as 1, if I enter B as 2, and I enter C as negative 8. Yeah, so we all believe that we know these roots, and one is a 2, another one is a negative 4. As you can see, we are seeing the roots are rare and distinct. So you can go back in our formula and see that the roots are rare and distinct. How do we describe it? It's given by negative b plus square root of discriminant, which is b squared minus 4ac out of 2a, and the other one is got by that. You get? So we can go on to seeing the imaginary ones, as you can run it again. So we can put 1, then we put a 3, a 3, and a 4. Yeah. So if I enter, you can see it's giving me imaginary values. So it's saying me roots are complex and conjugate of each other. As in our program, we did it. So it's giving me negative, negative. So in the form of root 1 is got by real part plus imaginary part I. And here is real part plus minus imaginary part, and as you can see, it's giving us the same thing because here we are seeing a plus and we're seeing a minus. So hence that's how programmers calculate the parts that were needed to calculate. So we thank you guys for listening to us. Thank you. We stay.
Yours, voice.
Thank you. Yeah. You